right, folks, here we are. So we're at the workbench. First thing you want to do is you want to make sure you have as reasonably flat of a work surface as you can. Trust but verify. My actual table has little undulations in it, so I have this piece of wood from an old cabinet, and I put it down across here, and I sight down and look and see if I see any gap, in here, and I don't. And then also take it across this way, diagonally. Again, if you see a big gap in there, there's a bow in there, and it's going to make getting things lined up properly, more of a pain for you. So I know that I've got a good flat surface here, within reasonable, it's flat. Okay, so I grabbed the already assembled lower torso just to show you. All right, so let me see here. Is that, yep. Okay, so, the idiot test here, is it square? Yep. Not rattling, not rattling, not rattling, not rattling. It's only resting on the four corners here. So I know that this is not, it's not twisted or warped or anything like that. But yeah, it is straight. It is fine. There's nothing wrong there. You can see our, I almost said rivets, our screws in the sides. I do have different color. I have black oxide fasteners in here because when I put in the prototype pieces here, I didn't have the correct length in stainless. Personally, I'm going all stainless on my robot. The black oxide's nice, but it rusts. And rust is bad. So, stainless steel is what I'm going with. Builder's choice. You do what you want. Okay, speaking of, so, internally here, you will see that there are these three printed pieces. These are 3D printed. They are 3D printed in my new material of choice, polycarbonate. Okay. This is Bamboo Labs black polycarbonate, and it is So, okay. I went and purchased a Bamboo X1 carbon before all the hype. I got it in I think February, and now that's all you see on YouTube. A shameless plug for Bamboo Lab. I absolutely love it. I'm old school. I started out with a Mendelmax. I think it was a MakerWorks Mendelmax 3D printer. You had to build it from scratch, and oh dear God. And then I eventually graduated to a Creality CRS-10 Pro. Did various upgrades on there. I got the X1 carbon with the AMS, and it prints absolutely phenomenally. I've had pretty much zero problems with it. And another reason here, so this is one of the finger segments. This was printed in this orientation, okay? I printed it in this orientation, so this was actually the bottom. So it printed this way, support material in here, okay? So as anyone that does 3D printing knows, these thin wall sections here, that's a weak point. Layer, it's going to break right there if you try to squeeze this. Well, this is polycarbonate, folks. Yeah. This stuff is, if you don't know what polycarbonate is, bullet resistant glass. That's what polycarbonate. Canopies and, fighter aircraft. I believe airplanes use the windscreens are polycarbonate. Anyhow, long story short, this is what we're building with. This is for the lower torso actuator. This is meant to distribute the forces instead of the forces being just through the fasteners into the aluminum. Down here, at this one point, this piece is now keyed into and screwed into all the various parts of the structures, and the forces are directed over a much larger area. So yeah, that's what this is. We designed this, and yeah, this will be in the CAD pretty soon, I do believe. Again, iteration, that's what we do. But yeah, Bambu Labs, yeah, if you're on the fence about it, dear God, just go get one. They're phenomenal. They yeah. I can't say enough about it. It's just a great printer. You know, you got a roll, you're at the end of the roll. You know, yeah, you just make sure you have another roll of like polycarbonate in there, and it will just switch to the other roll and continue printing. It's great. Yeah, and it's multi-material system, multicolor. I haven't gotten into that yet. But the thing is, for me, a 3D printer is a tool. I'm not in a 3D printing hobby. Okay, I don't want to have to become a 3D printing expert in order to make parts. Okay, I just want to design them. I want to print them. If I need to change something, iterate quickly, I do it. I don't have the time to monkey around figuring out all the intricacies and upgrade paths and you know, tinkering around with a 3D printer. I've had to do that because that's all that was available. You know, you bought a 3D printer, you knew when you got into it, you was going to have to monkey with it. You was going to have to spend money after the fact. With this Bambu Labs, yeah, it's an amazing machine. Okay, anyhow, lower torso. Here we go. So, lower torso, you can see everything is nice and skookum. Everything's aligned. I don't have the right length of hardware in here. We kind of have a discrepancy in the CAD. According to the CAD, 1/4 inch hardware should not be able to fit in here, but it, you know, it shouldn't be long enough. But for some reason it is. Yeah. But yeah, absolutely amazing. Send, cut, send. Yep. The pen fasteners are already installed. You just have to do the hard work and assemble it. So we'll get into that now. Here we go. So got our flat pieces there. We have the piece, which is problematic for us. And we have the bottom piece. So, and yeah. So this piece right here, this is warped. Okay? It is. Okay? Let me grab the straight edge of truth. And let me see, I'll go up to this camera here, put your straight edge on here, and yep, there we go. Can you see the gap? There we go. Maybe if I get my fingers out of the way. Yep, I think you can see that gap. You can see that bow in there. Yeah, fairly significant. It's even more apparent if I put this thing down like this. Yeah. Don't need no straight edge there. That's painfully obvious. So, why is this bent? Yep, this is laser cut by Send, Cut, Send, and they do all the bends, and then they put in the pen fasteners, and that's where the issue occurs. Basically, what is going on here is that since the material is thinner at the top and we can't really go thicker, you know, wider with this. I mean, technically we could, but yeah. Bottom line is, it stretches the material ever so much on this top edge here, which causes this top to expand. Okay, since this is a bent edge down here, and this is work hardened through the bending process, plus it's a bend, you know, a 90-degree bend, yeah, the material doesn't want to stretch at the bottom, so it does all of its stretching at the top. And of course, if you're talking, you know, between, you know, maybe something as little as 5/1000ths of an inch per fastener where it's stretching that material, you know, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 60 thousandths of an inch worth of material has to go somewhere, you know, that's what's creating that bend. So it's not the end of the world. This can be made flat, so we're going to do that. We're going to demonstrate how that's done. So first thing, you have your laser cut aluminum pieces here. They all need to be countersunk. So in order to keep yourself from doing a big old brain fart, what you're going to do is you're going to take two pieces together like this, just Sharpie them. Okay, something obvious. Pick it up, flip it over. Same thing. Don't worry, Sharpie removes with acetone. All right, now you know that the only place you're going to countersink on is where the X's are, okay? Just do it that way, okay? You see an X before you start countersinking, okay? Because if you countersink on an X side and then countersink on a non-X side, guess what? Yeah, you have two left or right side plates and there's no way to fix it. And Sencut gets to make you more parts. So, all right, cordless drill. I have DeWalt type. Thank you, Sean Fox, our team member. He bought this for me a couple of years ago, and this and an impact driver, and it is absolutely great. I am using this type of countersink. It seems to work the best. This is a Harbor Freight special, okay? I should probably get something better, but it is what it is. It's what I have. So, there are also this kind of countersinks, okay? And these I find chatter too much and they scallop. So I'm doing all this stuff by hand. All right. As far as driving in these 632 screws, all right? Yeah. You want to stay away from Allen keys, okay? And also, and I love the Wera, okay? I love these, okay? But at the smaller sizes, they strip out the fasteners, okay? They just do. It's physics. Yeah, good concept, but if you need to tighten things up, these tend to, you know, this is a 5/64 of an inch. It will round it out before you really can get a decent torque on it. The larger ones, it's not an issue because there's more surface area. So that kind of is what it is. So you can use this type here, okay? I got these McMaster-Carr. I ordered them from McMaster-Carr because McMaster-Carr, as a general rule, when it comes to selling stuff, does not sell junk. They're usually pretty good quality stuff. Not top tier, but good quality. I actually prefer this one, McMaster-Carr. There's actually a section of this still in here, but I pressed it in. I love this one, okay? Because this one has a very short range here, and then it goes up to a larger diameter here. It has some length to it, and I used a file handle, a wooden file handle to hold that all in there. And I find that these work great, okay? Good positive engagement in there. The longer that your hex is, the more likely is when you're trying to torque something down that it will actually twist the entire, you know, the entire hex. So I like these short ones, and I will say that that this one, I've actually broken one of these. Again, it's longer. I think it's just a little bit too much torsion in there, a little bit too much torque, and it fatigues it because it's so long, and eventually it just snaps. Or I could have had a bad one of them, but if you are going to use the short ones like this, okay, you want to try to make sure you keep the diameter of your handle down to as small as possible. Do not grab a big honking one like this with a larger diameter. Why is that? Because you've got more available torque there. It's going to be, you're more likely to strip out the screw head with one of these. I like one of these. Nice and light, and you can do that delicate touch. You can feel when things are starting to go sideways on you, and you can avoid disaster. Okay, so I have a bunch of holes here that I have to countersink. So I'm going to go ahead and countersink them. So what I've found works pretty well is I just offset this, okay, so that I can't see any aluminum. I'm going to do the top holes here, okay, and my video editor will probably, more than likely, do a quick little montage of me drilling these out. And you're going to test fit with one of the actual fasteners. Now, when you first do this, you don't have to go down to a perfect depth, okay? I'll be showing that, but yeah, so. So we have all of our holes that we want countersunk started. Okay, this is not the end result. You know, this is just to get them started. You know, put the fastener in there; it will stand proud. That's okay. Nope. We just want to get them started. All right. So now we've got our work piece. So the basic concept and premise here is that you start at one end and work your way to the other. What I've done is I've just done a preliminary countersinking of all of these. They don't have to be, you know, perfect, accurate. Yeah, they just, yep, you've got to get them in there. You will tweak them, fine tune them at a later date. So here's what we do. Grab one of our plates, put it down here, line things up. We find the first hole. Grab a fastener and stick it through here. Come on. Come on, go in your hole. There you go. All right, so what am I doing? Just tightening this up a little bit. Okay, not much. I actually want a little bit of wiggle in here. Okay, see that? A little bit of rock and roll. That's the name of the game here. A little bit of rock and roll. Okay, I'm going to put a second fastener in this side as to keep this from wiggling around. Come on, go in your hole. There we go. Okay, do not force the fasteners in here. They should go right in. Okay, so you bring it down to where it just bottoms out a little bit and then back off. Again, we want rock and roll. Now after we've got the first two in there, we go back here. We do the same thing to the other side. Are you able to see what I'm doing? Yeah, I guess you can. Jesus. 3 cameras. If you can't see on 3 cameras, well, I don't know what to tell you. So, putting these in here. All right, so I've got 2 of these in here. So, I don't know if you can tell, but this end of these plates are sticking up. This end down here, you know, if I press them down, there we go. There you can probably see. Let me do a sideways view for the one camera here. So if I press them down, yep, see how far they're sticking up there? If I get my fingers out of the way, yeah. That's a little bit of a gap. So, stand up for this. Now I'm going to start working from one side to the other, okay? What I'm going to do is I'm going to press down on this, okay? I'm pressing down on the plate. I'm now going to tighten this, snug this up. I'm not going to tighten it, going to snug it. There we go. Go to the other side, same thing. Press down, snug it up. Okay, now I've got that concentric with that countersink. Now I go to the, now what I'm going to do is I'm going to press down here, okay? So I'm pressing down and I'm going to tighten the second one over here. Okay, good there. I go to the same thing here. Press down, snug it up. All right, I go back to this other side. Rinse and repeat, folks. Press down. Actually, you got to run the fastener in first, sorry. Got to get the fastener in there, and see, this is the thing. It's not going to want to go in there necessarily. We are convincing it to go in here. So, and there again, I may have to wiggle this plate back and forth. Okay, you can sight down through it. I can see where the hole needs to go. I can see that the threaded PEM fastener actually needs to come out a little bit, so I'm pressing up a little bit, and that will bring it to where it wants to be. There it goes. Okay. Again, make sure we are pressed down at the back. We're good. We come up here. Press down. Tighten one up. We're just snugging it. I shouldn't really say tight, but we are snugging it. I'm going to keep flipping this around because it is easier for me to manipulate the driver. There we go. I can go back to this one. See again, it doesn't want to go in. I can see that that wants to go out, so I'm just pulling this out a little bit. There we go. Now it's going in there. It's happy. Put it back down, press it back down. And you can see I gotta, yep, I need to apply some force there. Press it down. Alrighty then, so that portion is done. See that? Nothing. Yay for me! Alrighty, so you're almost there. Now you need to do the bottom portion, okay? But as you can see, there's no more bow. Yeah, you've addressed that particular problem. Okay, next piece. Alright, so on this one, there are two, I'll go to this camera. There is one that has an angled cut, one side that has an angled cut, one side that does not, okay? The side that, actually, I don't want to steer you wrong here, and I certainly don't want to put it together wrong. Yeah, the angle down at the bottom. So, you're going to assemble this like this. You're going to put this in here, down here. You're going to work from here around, okay? This way you have the most leverage and the most, you can grab stuff the easiest. So, put that in there, line up the first hole, okay? This is the same basic thing. These pieces may have an ever so slight bend to them. It's the nature of the beast. It is what it is. Deal with it. Move on, snowflake. Yeah. Yeah. It's not like you can run to Walmart and pick one of these things up. They're unique, custom units. Please assemble. There we go. Okay, so I got the first two in there. Yeah, a little bit of rock and roll. I'm going to go ahead. These ones here are not too terribly bad. Actually, you can see how the screws appear to be going right in. So if there is any rock and roll or warp in there, it is so extremely minimal as to be non-existent, because these are just going right in, so not a problem. And I ran into that on the last one. Okay, so now what I'm going to do is I'm going to take and I'm going to put in, tighten it down. I should say snug it up, not tighten. There we go. I go to this next one. That over here. Rinse and repeat, back and forth. Working our way from here forward. This side. I like to alternate sides. Pretty much the same thing when you're torquing down bolts on the head of an engine, or putting on lug nuts on the tire. You try to alternate it. Yeah, it's science, reason. Just do it because people tell you to do it. People that know what they're doing. Yeah. So they tell you to do it for a reason. Here, and again, this side. See, sometimes the bend can be slightly off, but Sencut sand is actually pretty darn amazing. Let's see this here. Yeah. That screw has a little bit of something going on there. Again, while you're driving these screws in, you are paying attention. See, something's going on there. What could be going on there? I don't want to force anything in there. It looks like okay, so I'm going to take and I'm going to back some of these out because it looks looks like I got one fastener that is slightly out of alignment, enough to where it wants, yep, see? So by loosening that up, I've just given that rock and roll. Gotta run this in there. See if it can find it. There we go. Now it found its happy place. Don't force things, okay? So that one is good. Okay, so I gotta go back here. Get this one in. I already know these lined up pretty darn good as it was. Alright, so there's that one, there's that one, those two are loose. I'm going to do a sanity check here. We are... push there with my thumb, just kind of pushing it there with my thumb. Need a little bit of pressure. All right, so got that. Back here. All right, still feels pretty darn good to me. I'm just kind of holding down some pressure here with my hand. Make sure things are kind of staying where I want them to stay. Again, this seems to be pretty much perfectly aligned right out of the box. Side. Here we go. Yay! There we go, folks. That's how you do it. Yeah. Perfect. Yes, yes. So, all these are just preliminary countersinks, okay? What I do after this is I will go back and I will go like, you know, I'll just show you here, just for shits and giggles. So, okay, this one's sticking high, right? So what I do is I won't start the end one first. I'll start on the middle ones, okay? So I'll go every other one, okay? So just imagine, yeah, so I'm not gonna start here. This one here, it's a little bit proud. It's a little bit high. This one here, same thing, but I start here. I'm gonna back this out, okay? Yay! There we go. I haven't disturbed anything because the other screws are holding everything into position. Now I can go ahead and I can go back and I can tweak that hole. Okay? And don't worry if it doesn't, if the countersink looks a little oblong or whatever. First of all, it's covered. Nobody sees it. Second of all, yeah, who cares? But you do want to make sure that these countersunk screws, okay, it's still sticking up, are a little bit below the surface. Okay, so I just go back here again, hit it again. See that? I remove that much material there. Okay, and run that down again. Whoa, I think that'll do her. That's it. Below the surface. That's what you're done. Okay? You're done. Just, yeah, move on. There we go. Tweak it up. That's it. That's all the tire. Yep. That's all the tire you ever go. Okay? No impact driver. No. Light touch here. Okay? So, I'll do one more here. Just show you. Back. You notice I skipped this one? Go to this one. Okay? And try it in there. Nope, still sticking up. I can feel it just a tiny bit, so. There we go. Oh, that felt good. I think. Yep, there we go. Easy peasy lemon squeezy. So there you go. Rinse and repeat. Okay? Yeah. Yep. You just roll with it, folks. Not rocket science. We're not building a Mars rover here. But there again, you do want to take pride in your work. And yeah. So, oh wow. I see I'm up on an hour. Yeah. Hopefully you guys haven't had to sit through an hour. Hopefully Sean did some magical editing. But there you go. Yeah. So the open sink lower torso PEM fastener version, freely available to anyone and everyone. Play nice. And yeah, join our Facebook group, please. And Thomas LeBlanc. Again, thank you. Yep, this is something we were aware of. I wasn't aware that it was actually had already been included in the CAD, this newest iteration. But yeah, that is what it is. Sometimes, yep, you get things in from fabricators, manufacturers, and there again, we're not sheet metal experts on this project. Yeah, something like this happens. It's like, oh, okay, that sucks, but how do we, roll with it? And this is how we roll with it, and it's perfectly fine. Yep, there we go. Okay, so yeah, Facebook group, Patreons. Yes, thank you, Patreons. We love y'all. Yep, keep supporting us. Let me see, input-inc.com is our website. So yeah, Facebook, our Facebook group, our Patreon, and yeah. And yeah, give a subscribe, give a like. Yeah, I appreciate that. So, and shout out to Ramon and Sean Fox, which is going to be doing the video editing. And we finally, hopefully, got the camera situation figured out now. Yeah, that was creating issues. So, there we go. All right, so that's it. Terry Andrews Jr., J5 Guru saying bye for now, and go build yourself a cool lower torso.